As we continue our study of area, we now move on to area of trapezoids, triangles, kites, and rhombi. The first one we're going to talk about is a parallelogram. You have seen these areas before, so we're just going to refresh your memory on the formulas for it. First off, we have area of a trapezoid, area of a parallelogram is area equals base times height. Base times height for the area of a parallelogram. Now if we look at where that comes from, if we look at the diagonal, what does the diagonal do to a parallelogram? Here we have a diagonal drawn in the orange parallelogram. Well, actually that cuts it into two triangles. And if we think of the area of two triangles, we have two triangles which are both 1/2 base height. That would be the area of a triangle. And if we multiply that by 2, 2 and 2 cancel out, and I'm left with just base times height. That's where that area of a trapezoid can come, or area of a parallelogram can come from, is when we cut the parallelogram into two congruent triangles, we have base times height when we combine their areas. There we are, the area of a triangle. You just saw I wrote down the area of a triangle is 1/2 base height. Again, this is something that you have learned before, but we want to look at the actual, where does the base come from and where does the height come from? Well, a triangle actually could have 3 different bases. Any side of a triangle could actually be called a base. I'm going to start out by calling this piece right here the base. If you remember when I talked the last presentation, the base and the height always have to meet at a right angle. Therefore, in this question, we would need to go from the vertice there to make a right angle, and now we would have our height. So the height and the base always have to meet at right angles. The red line I just drew is the base, the other red line is the height. There's one way we could look at it. Well, here's another example, that exact same triangle. What if I called this the base over here? Outlined in red. Well, the height can't go just to right here. That wouldn't be acceptable for a height to be calling that the height, because that's obviously not the true height of the triangle. What we need to do in this case is we need to extend this base. And then I'm going to bring down the height. Now we have the height located as this dotted line on the far left. The height and the base have to meet at a right angle. Lastly, I could have this piece be the base. Again, the base and the height have to meet at a right angle, so I'm going to need to extend and extend down to get the height way over here on the right hand side. So as we look at the height and the base, the key is they have to meet at right angles, and that will be true every time we talk about a height. Next we have the trapezoid, area of a trapezoid. To find the area of a trapezoid, we are actually going to find the median of the trapezoid, which if you remember from chapter 8, we find the median by taking base 1 plus base 2 divided by 2. We're finding the average of the two bases. Once we find those averages, we take that times the height, and we'll have the area of a trapezoid. Notice again here, the height of the trapezoid is going perpendicular between the bases. It is not over on the two slanty sides. The two slanty sides can never, ever, ever be used to find the area. They can't be a height. So there we have the formula for the area of a trapezoid. Next we have a rhombus. As you'll remember back from our study of rhombus in chapter 8, a rhombus is just a parallelogram. So the first formula we're going to use for a rhombus is simply base times height, because a rhombus is a form of a parallelogram. Our other area formula for a rhombus uses the diagonals. We have diagonal 1 and diagonal 2. It's a fairly simple formula, and it is area is equal to diagonal 1 times diagonal 2 divided by 2. We just take and multiply the two diagonals together and then divide it by 2. This same formula can be used with a kite, but it can only be used for the rhombus and the kite. The diagonals cannot be used with any other shape to find area in this way. Again, the area is going to equal diagonal 1 times diagonal 2 divided by 2. Our last part of our lesson for today is let's just try and find the area of this trapezoid, or the missing piece of this trapezoid. We're trying to find the height. So we have a bunch of information. We have a base that's 120, another base that's 10, and we're missing the red height. What we'd like for you to do in this type of a problem is to always first write down the formula that you're going to use. The formula for a trapezoid is area equals base 1 plus base 2 over 2 times height. In this question, we already know that the area is 120, but what we don't know is the height. Let's plug in what we know. The area is 120, base 1 is 10, base 2 is 20, and we have an unknown height. What we want to do is actually just solve this and simplify this as an algebraic equation. We have 120 equals 30 over 2 h, or 120 equals 15 h. Divide by 15, divide by 15, and we will get h equals 8. We now know what the height is. We can go back in here and say that the height is 8. That's the end of that lesson on areas. Make sure you've gotten all those area formulas written down. If you missed any of them, make sure to rewind them, or if any of them didn't make sense, make sure to come back to class and ask me about them.